So here in this video, we're going to talk about the mixture of weak acid, the calculating of pH series, the mixture of weak acid. We have already seen that how do we calculate the pH of a strong acid and weak acid, and we have mixed strong with weak, and we have mixed both the strong. So all the possibility we're going to cover. Now there is also one possibility that we mix two weak acids. We could mix two weak acids also. So what the common ion will be here? Common ion would be H plus. H plus will be common in both. So in this case, common ion effect will operate on both weak acids. So common ion effect will affect both the alpha of the weak acid, right? We have seen the common ion in one should be strong and another should be weak, but it will affect only weak. When both are weak, then it will obviously affect both of them, and effect will be on electrolyte which is more. So obviously the electrolyte which is more weaker, which has already less alpha, then effect will be observed more in that case. So if we try to derive how do we calculate the pH, if we try to see the process how do we calculate, let's start that we have an acid HA1 which dissociates like H plus and A1 negative, right? So initial concentration was C1. Now after dissociating into constituent ions, C1 minus C1 alpha 1, and here it becomes C1 alpha 1, and here also C1 alpha 1. Now in the container, same container, we have another acids like another acid HA2. HA2 dissociates like H plus plus A2 negative. So here it is C2, C2 minus C2 alpha 2, and C2 alpha 2 and C2 alpha 2. So here C1 alpha 1, C1 alpha 1, we will be adding both. As I always say that whenever both are present in the same container, doesn't matter that H plus is coming from that. We will be including all the H plus in that and all the H plus in that because they are in the same container. Okay, it doesn't know that both H plus are different. No, both H plus it will treat the same. So you will count all the H plus here, which was C1 alpha 1 through this and C2 alpha 2 from this. So we will be using both C1 alpha 1 plus C2 alpha 2. Now let's jump to the further calculation. Now we know for first acid, let's say the dissociation constant for the acid is Ka1 and it is Ka2. Now Ka1 is concentration of H plus A1 minus upon HA1. So H plus is C1 alpha 1 plus C2 alpha 2. A1 negative is C1 alpha 1 divided by C1 into 1 minus alpha 1. So we know whenever we are talking about weak acid, we have to neglect that alpha 1, because if we don't neglect, we will do the assumption that it could be greater than 5%, that the situation to calculate the pH will become very complex. And since both are weak and due to common ion effect, the alpha also suppressed. So eventually we have to consider that alpha is very negligible with respect to 1. So we will be neglecting the alpha. Now Ka2 comes out to be H plus into A2 minus divided by HA2. Here it is C1 alpha 1 plus C2 alpha 2 into C2 alpha 2 upon C2 1 minus alpha 2. That also becomes R0. That is Ka2. Now If we divide, let's give this equation as 1 and it is as 2. So we divide 1 over 2. So Ka1 upon Ka2 comes out to be alpha 1 upon alpha 2. Now alpha 1 comes out to be Ka1 upon Ka2 into alpha 2. So all these terms, C1 alpha 1 plus C2 alpha 2, this all will be coming cancel out. This all will be cancel out. The alpha 1 is coming out to be Ka1 Ka2 into alpha 2. Now if we use that alpha 1 that come out, if we use the value of in equation 1, if we put the value of alpha 1 in equation 1, Ka1 comes out to be C1 into Ka1 upon Ka2 into alpha 2 plus C2 into alpha 2, right? C1 alpha 1, C2 alpha 2, alpha 1 we have put it this value into Ka1 divided by Ka2 into alpha 2. Now if we use the value like if we taking out common like Ka2, if we taking out common alpha 2 over here and we divide it by all the by Ka1, so 1 will be equals to C1 Ka1 plus C2 and it is Ka2 upon all the term Ka2 into alpha 1 square divided by Ka2. Now alpha comes out to be right Ka2 upon under root of C1 alpha 1 plus C2 alpha 2. The alpha 1 that comes out to be this Ka2 that Ka2 upon C1 alpha 1 C1 Ka1 right, it is not alpha 1, it is Ka1 C1 Ka1 plus C2 Ka2. If we use this alpha and if you take all the cross multiply all this, you will get this term. So the constant similarly this is alpha 1, alpha 2 comes out to be Ka1 and over the root of C1 Ka1 plus C2 Ka2. Now we know on the concentration of H plus is C1 alpha 1 plus C2 alpha 2, right? So C1 alpha 1 we put Ka2 first of all there is a little bit change like it is Ka2, right? And here it is alpha 2, right? It is alpha 2. We have to make a little bit correction. It is alpha 2 Ka2 and it is alpha 1 will be Ka1. Okay, right? Alpha 2 is to Ka2. Now we C1 Ka1 over the root of C1 Ka1 plus C2 Ka2 plus alpha 2 into C2 alpha 2 is Ka2 upon under root of C1 Ka1 plus C2 Ka2. That is the concentration of H plus. So the concentration of H plus comes out to be over the root of C1 Ka1 plus C2 Ka2. So if we mix more than one weak base, so we can give the generalized formula like summation over Ki Ci. Ki Ci, generalized formula Ki Ci. And the concentration of H plus we could give the final formula over the root of sigma of Ki Ci plus Kw. If we consider if water is, now when we will consider the water, when you see that the concentration of H plus is coming in the range of 10 to power minus 6, 10 to power minus 7, the concentration of H plus is not that much strong. So that in case of Kw we have to include, then you will be including the Kw. Now we have given an illustration that we have two weak base, 0.1 molar HA1 and Ka1 is given, like we could write Ka1, and 0.2 molar HA2, the Ka2 is given. Calculate the concentration H plus A1 minus A2 minus and OH minus in the solution. So if we see the formula, concentration of H plus comes out to be over the root of sigma Ki into Ci. So over the root of sigma Ki 10 to the power minus 5 into Ci 0.1 plus 4 into 10 to the power minus 5 into 0.2. So it is 3 into 10 to the power minus 3. 3 into 10 to the power minus 3. So concentration of OH negative is coming out to me. This 0.8 and 1 you can calculate easily. It is 6 into 10 to power 9 into 10 to the power minus 6. So it is coming out to me 3 into. Now concentration of OH negative will be Kw divided by H plus, and Kw is 10 to the power minus 14 divided by H plus is 3 into 10 to the power minus 3. So concentration of OH minus coming out to me this 10 to the power minus 11 over 3. Now we have calculated the H plus and OH negative. Now we have to calculate the A1 negative and A2 negative in the solution. So we will be using the acid formula HA1 for HA1. We know K1 is 10 to the power negative 5 and the concentration H plus is 3 into 10 to the power minus 3, and here it is A negative and the this is 0.1. So A negative is 10 to the power minus 3 over 3. Similarly HA2, we use the K2 is 4 into 10 to the power minus 6. 3 into 10 to the power minus 3 is the H plus. This is A1 negative and A2 negative over concentration 0.2. So A2 negative is 8 by 3 into 10 to the power minus 3.